So we are talking about lesson 5.1, operations with polynomials. All right, so this chapter, guys, is all about polynomials, and today
Miss L.
we're focusing on exponents, All right, so we're gonna be practicing a lot today. So we are doing a bunch of simplifying today. Now, simplifying really just means like you need to make sure you have no negative exponents, okay? You need to have, parentheses taken care of, any exponents to another exponent's taken care of. Bases only appear once. All right, so there's a lot of these things that you have to make sure of to call it simplified. Right? And so these properties are going to help us in that simplifying process. So let's look at this first one. Let's see what you guys actually know already. Maybe. Okay, so a to the m times a to the n. Does anyone know what you're supposed to do with those exponents if you multiply?
Add.
Ooh, yes, thank Gio. Yeah, so you add those exponents. So you keep the same base, and then you add the exponents together. Perfect. Michael, you good now? No. I would double check. Maybe you need to update your Zoom. I don't know. That's weird. But okay. You have your notes in front of you though, right? Okay. So hopefully you can still follow along. All right. So we'll call this property number 1. Go ahead and number these properties because I'm going to be referencing them by number. So you'll know which one I'm talking about. Okay, so stands to reason then, if I have a to the m times a to the n, and I add the exponents there, if I have a to the m over a to the n, I'm dividing, what do you guys think I'm going to do with these exponents?
Subtract.
Subtract, nice. All right, so then we subtract them when we divide. All right, we're going to call that property number 2. All right, property number 3, if I have power to a power, I have an exponent and I'm taking it to another exponent. Does anyone know what I do with these exponents?
Multiply.
Ooh, Gio's on fire. Nice. Multiply. Perfect. So that's a to the power of m times n. Good. Call that property number 3. Property number 4, a times b. Notice I have 2 things in the base now. A little different than property number 3. 2 things in the base. What I do here is I give each factor of the base the exponent. So this will be a to the m times b to the m. And we'll call this property number 4. Now, let me give you guys a warning here because I see so many students do this, even in like honors, even in like AP classes. I see students do this all the time. Please do not do this. A plus b to the m is equal to a to the m plus b to the m. Not true. Not true. Okay. I understand completely why people would do that because it looks very correct, right? It looks right. But this is not a property, guys. That is actually not true. So warning, do not do. This is not true. And I'm going to make a mad face here. Okay. So do not do that. When it's minus, same thing. You cannot do this. All right. Only if the bases are being multiplied. Only if the bases are being multiplied. All right. Sweet. Let's go on to this next one. So we got a over b to the n. Same thing as the previous one, where you give each base its own exponent. All right. And that's property number 5. Okay. Next one. When you have negative exponents, whenever you guys have negative exponents, to simplify, you have to make it positive. So to make it positive, you do the reciprocal. Okay? To make a negative exponent positive, you do the reciprocal. And so that's b to the n over a to the n. All right, we'll call that property number 6. That actually goes really well with this bottom part. So let me jump to this real quick. That means if I have a to the negative n, to make that positive, I bring it down. Okay. But if it's already on the bottom and it's negative, to make it positive, I bring it up. All right. So that's how you handle these negative exponents. Do the reciprocal. If it's on top, bring it to the bottom. If it's on bottom and it's negative, bring it up top to make it positive. All right, any questions on that? All right, then that property right in the middle, a to the 0 power. Does anybody know what a to the 0 power is going to be? Queenie, just say it.
1.
1. Good. A to the 0 power is just the number 1. All right. And that is true for any value of a except for 0. That's actually true for every value of a except for 0. So 2 to the 2nd power is equal to 1. Negative 500 to the 0 power is equal to 1. All right. 2 over 3 to the 0 power is equal to 1. The only thing that it's not equal to 1 is when it's 0 to the 0 power. That's actually undefined. This one's not equal to 1. Okay. Questions on any of our 8 properties that we'll be using today? Okay, let's try it, guys. So I'm going to do the odd ones, and then I'm going to call on people for the even ones. All right, so let's jump right in. So starting with number 1, we are asked to simplify, assuming no variable equals to 0. Okay. So number 1, I see I have 2 bases, all right, or the same base being multiplied. So I'm going to look at property number 1, right? That looks just like property number 1. So I'm going to add the exponents, 7 plus 8. So that gets you m to the 15th. And I'm just going to put the number 1 there, just so in your notes, if you guys are studying, you can like see like, okay, which property did I use? Oh, I used property number 1 to do that. Okay. On your work on the quiz, you don't have to do that. This is just for studying purposes. Okay. All right. I'll save number 2 for you guys. Number 3. Number 3, I have an exponent to another exponent. So this is like number 3, property number 3. So I'm going to multiply those exponents together. So property number 3 allows me to make this a to the 20th. All right. And that's it for number 3. Okay, number 5. Number 5, what I would actually do before I start handling that exponent is see if you can simplify the inside first. It makes it a lot easier if you can. So let's simplify the inside. So x squared divided by x to the first. This is my second property that allows me to subtract those exponents. So I have x to the 2 minus 1, and then y to the 1 minus 3. So that's going to be x to the first, y to the negative 2. All right, don't forget that square on the outside still. All right, so that's using property number 2. Now using property number 1, 2, 3, 4, I can give each part of that base the exponent of 2. So this will be x squared, and this would be x, or sorry, y to the -4. All right, now I can't have negative exponents. So I need to, using property number 8, make that positive by bringing it down to the denominator. So that's x to the 2nd over y to the 4th. All right. And that's that. Questions on that one? All right, then number 7. Okay, so number 7, I would technically, simplify the inside first, but actually that -1, the outside, is so like simple to handle that I'm just gonna go ahead and do the reciprocal first using property number 6. I'm gonna flip that whole thing around. To make that just to the +1. All right, so do the whole thing, flip around to make that +1. All right, and then now I'm going to use property number 2, and I'm going to subtract those exponents. So -3 minus 2 for the a base, and then b to the 2 minus 1. All right, and that gets me a to the -5 times b to the 1st. And that -5, property number 8, needs to be brought down to the denominator to make that exponent positive. So final answer, b over a to the 5th. All right, and that was number 7. Okay. Ooh, number 9. Easy. No work needed. This is just what? What is the final answer for number 9?
1.
1, yes. Love this problem. Doesn't matter how complicated things are inside the parentheses, it's to the 0 power. So property number 7, that's just equal to 1. Done. All right, number 11. All right, number 11, I'm going to use property number 2, and I get 2 to the 3 minus 2 exponent, c to the 4 minus 4, and t to the 2 minus 2. Simplify that, I get 2 to the 1st, c to the 0, t to the 0. Property number 7, that's just 2 times 1 times 1, which leaves me with 2. And that's it. All right, guys, any questions before I start calling on people? Solid. Okay, let's do it. Okay, jump into the even. So number 2, I'm gonna start calling on people. Get yourself ready. And you don't have to tell me what property you're using. You can just go ahead and tell me how you would simplify. Let's see, Michael, I'm gonna start with you for number 2. Go ahead and just tell me what you would do.
So I would use the product of powers property.
Okay, and what would that do for you?
And it would be C12 plus -4 plus 6.
Good, all right. And what does that simplify to be?
Hold on.
Okay, 12 minus 4 gets you
8.
And then plus 6.
14.
Perfect, you got it. All right, so C to the 14th. Nicely done. Michael. All right, number 4. Let's go to Ryan. All right, Ryan, what do I do?
So you subtract from top to bottom since they have the same variable.
Mm-hmm.
So the final answer would be b to the power of the 6.
Perfect. All right, subtract those exponents. Final answer, b to the 6. You got it. All right, and that is number 4. Good. All right, going to number 6. Let's go to Gino. All right, Gino, help me with number 6.
I'm actually not so sure about this one, but
Fine.
I flipped both sides, I guess,
Okay.
from bottom to top.
Okay.
And then in the end, I ended up with x squared.
Oh, okay. I would be a little careful, especially, yeah, because there's so many of these negatives. Maybe use property number 2 first before you start moving things around. So what I mean by that is just focusing on the x's, right? When we divide, what do we do with those exponents?
Subtract them.
Yeah, so this would be -2 minus 4. And then y, this is 1. So this would be 1 minus -1. So can you help me from there? X to the
-6,
and then y to the
2.
and then to
Right.
handle that negative.
Oh, so then it's y squared over x 6.
There you go. All right, good. Yeah, so I would do that first. I think it's just a little easier in terms of handling those negatives at the end. Yeah. All right, good job, Gino. Nice. Okay, let's go to number 8.
You just put n on the bottom and make
Thank
it bottom
you.
one.
All right, so just put n on the bottom and that handles the negative exponent. That's property number 8. Property
Okay.
number 8. Okay. All right, Gavin, you need to, right?
Yep.
Okay. All right. Number 10. All right, number 10. Let's go to Heidi. All right, Heidi, help me with this one.
I think you would go with distributing it.
Kind of.
Yeah, I was a little bit lost with this part just because it was different from the
Yeah.
dividing and that, but
This one's a little bit different. So I'll help you out with this one to start you. Look at just the numbers first. The 4, the -1, and 3. Start with multiplying those first.
okay.
So what do we
Right.
get when you do 4 times -1 times 3?
Yeah, so you would get -12.
There you go. Okay. So now, because there's a lot going on, focus just on the J's.
Okay.
So what property can I use and what do I do with those exponents?
You would add them.
Good.
So
So
-2 plus 3, so that would be j to the just j, I think. Or to the 1.
we got 1 plus -2 plus 3.
Oh, sorry, I forgot about the 4j on the outside.
Yeah.
That would be 2.
There you go. All right, good. And then focus on the K's.
And that would be k to the -4th.
Oh, careful.
Or -5th, sorry.
Yeah. Okay. Now, can't have a negative. So what do I do?
You put it on the bottom.
There you go. All right. So -12 j the second over k to the 5th. Final answer. All right. So yeah, when you get a problem like that, it looks super overwhelming.
Yeah.
Chunk it up. Yeah.
Okay.
Chunk it up. And then that way it's a lot easier. Good. All right. Let's move on to number 12. Okay. So number 12, Mason, help me out with this one.
Okay. So first thing I would do is, wait, can you combine the 2mn with the stuff in the parentheses?
No, the reason why is because it has that square. So I would handle the square first.
Okay. So you would add 3m squared by the square root. So it would be 3m4 times n
Square the
squared.
3 3. So using
Oh,
property,
so 9 and 4.
Yeah. using property
Okay.
4, you would square the 3. So we get 9m to the
4th power.
n to the
And the 2nd power.
perfect. Okay. Go ahead and simplify the numerator. So multiply just those numerators together. And what do we get?
Okay, so we get 18. Wait, so the m has 1, the 2m has 1, right?
Exactly. Uh-huh.
Okay, so it'd be 18m to the 5th power
Mhm.
times n to the 4th power.
Perfect. Good. Over what we already had. Okay. And then now let's simplify. 18 over 2, or sorry, 18 over 12. What does that reduce down to?
3 over 2?
Mhm. Good. All right. So
Okay.
3 over 2, and then m to the 5th over m to the 3rd.
That'd be m to the 2nd power on the bottom,
Oh,
right? Oh, on the top, I mean.
on the top, because it's 5 minus 2, it's positive. So it would stay on
Yeah.
top. And then n to the 4th over n to the 4th, what happens there?
You get n to the 0th power, which gives you 1.
Exactly. All right. So final answer.
3m squared over 2.
Perfect. That's it. You got it. All right. Good job, Mason. Okay, guys, any questions on our examples? The reason why we have so many is because exponents take a lot of practice. All right. Okay. All right. Let me go ahead and help you guys out with these last types of problems. I'm going to save 13 and 14 for you guys to practice a little bit more. So I'll save those for you guys later. Let's jump to number 15. And I'll show you a little trick I do to kind of make life a little easier when it comes to these problems. Oh, actually, sorry. Not, well, I guess you can do it for this one too. So basically, I need to combine like terms, right? So here I have a negative. So I'm going to be really, really careful with this. And I'm going to distribute that negative to make sure I don't make any careless mistakes. All right. Now, some of you guys are totally fine going from here. What you can do is you can stack your like terms if that's a little bit easier for you to visually combine. All right. So you can feel free to stack it, and that way it might be just a little bit easier to combine like terms that way. All right. So that's just a little trick you can do. And I get 2x squared minus 4x plus 5. 2x squared minus 4x plus 5. All right, let me show you guys number 16 because it looks a little scary. But it's not that scary, okay? Don't worry. You're just combining like terms. So I have an x squared term here, and I have an x squared term here. I need a common denominator, so I'm going to make this 2 over 8 minus 3 over 8 gets me negative 1 over 8 x squared. All right, so not too bad. Then I have my xy term and an xy term here. Get a common denominator, so the negative 1/2 will be a negative 4 over 8. Combining those gets me negative 7 over 8 xy. All right, and then our y square and y square, get a common denominator of 4. I get 2 over 4 plus 1 over 4, giving me 3 over 4 y squared. All right, and that is my very colorful final answer. Okay, let me do a couple more and then I'll have you guys practice. So number 17. All right, number 17, I need to distribute. All right, so I can distribute the 2n square to the n squared, giving me 2n to the fourth. Distribute 2n squared times 5n gets me positive 10n to the third. And distribute, I get negative 2n squared. Now here's my trick again. Stack your like terms. Negative 3 times n squared, I'm going to put that negative 3n squared underneath my other n squared. So it's easier to combine. Distribute, I get negative 15n. Distribute, I get positive 3. And now when I add that up together, I get 2n to the fourth plus 10n cubed minus 5n squared minus 15n plus 3. Final answer. All right, so I really like stacking my like terms because I think it just helps with careless mistakes. I don't miss anything, and it's just easier visually. All right, number 18. Ooh, let me tell you guys, number 18. I have honors students, I have AP students who are seniors who would do this. Duh. Okay, this was my warning. Remember from before with my angry face? All right, that will be my face, guys. If you do this on the quiz, there's the face. Okay, that will be my face, guys. Do not do this. And no matter how much I say it, there's always somebody that does. So do not let it be you. Okay. No, foolishness, right? This is just foolishness. Don't do that. Instead, you guys are smarter and better than that because you know instead that this is x minus 3, or sorry, x minus 5 times x minus 5 times x minus 5 3 times. Okay? So multiply. I'm going to multiply these two at the end together, and I get x squared minus 10x plus 25. And then I distribute. So I'm going to distribute the x to get me x cubed minus 10x squared plus 25x. And then I'm going to multiply the negative 5x squared and put it underneath the negative 10x squared, stacking my like terms, plus 50x minus 125. Combine that up and we get x to the third minus 15x squared plus 75x minus 125. And that is my final answer, which is so different compared to that one up there. Okay, don't do that. All right. Questions on that?
I had a question. I'm not positive if this is even possible.
Okay, yeah.
Because for the most part, these equations end up being in this order. But if you were to get a problem where it would be like x to the third and then the x and then the x squared, would you have to put it in order of x to the third, x squared, or x cubed, x squared, x?
Oh,
yeah, like if it wasn't in order, or is that?
Yeah, so if you have like x to the third, let's say minus 2x plus 4x squared, like something like that. Yeah, you do want to put that in order from highest exponent to the lowest exponent like that.
Okay.
Yeah. Mm-hmm.
Is that even possible? Like, because most of these problems end up just being like in order by themselves.
I would say yes, it is possible, but for the most part, it ends up being in order kind of nicely. But it is possible. It is possible. It's a good question. Yeah, good question. All right, sweet. You know what? Let's have you guys practice with number 13 and 14 right now. So getting a good handle on these exponents, try 13 and 14, and then I'll see how you guys do. So I will give you like 5 minutes. Okay, Faith, start us off with number 13.
Okay, so I started by multiplying, distributing the second power into the -5 mn.
Mm-hmm.
So, and then I got -5 m to the second power and n to the second power, but then also -5 has the second power. I forgot.
Oh yeah, so that should be 25.
Yeah.
Uh-huh.
Yes. And then after that, I multiplied the m's together, or the exponents, and then I got, for the m, I got 6.
Mm-hmm.
And then for the n, it was 0.
Mm-hmm.
And then, are we supposed to also put the numbers together too?
Yes.
Oh, okay. So then it would be 3 times -25, which would be -75.
Yes, except positive, because -5
We had to put,
squared.
oh, okay. Yeah. Okay. Sorry.
Yeah, no worries. So 75 m to the 6, and that's it. You got it. Nice. Okay, thank you, Faith. Number 14. Let's go to James. All right, James, help me with number 14. James. Uh-oh, James? I can't hear you. Ah, okay. It's okay, James. We're running out of time, so you are off the hook. All right. So this one I would do, this is -1. So -1 to the third, m to the 4th to the third. All right. So that will give me -1 m to the 12th. Okay. This actually, because of this being negative, I'm going to bring that up. So that is going to be 2m squared to the +2 on the numerator. So I actually don't even need a denominator anymore, technically. All right. So that negative, I can bring that whole thing up. So this will be 4m to the 4th. And -1 times 4 gets me -4. And then m to the 12th times n to the 4th gets me m to the 16th. And that is my final answer. All right, so just kind of handling that negative to start with. All right, guys, I know it's the end of time, but let me give you the answer to the last one, just in case you did it. And even if you didn't, you can just have it down to check your answer later on. All right, so final answer, we get 2x cubed plus 4x squared minus 3x cubic units. All right, and that is it. Okay, thank you guys.